Okay, I think I'm broadcasting. Okay, hey everybody, welcome back. I know it's Future in Space Hangout time here at Deep Astronomy. I'm so glad we're back doing this today. We're going to be talking about sustainable lunar operations. Now, I know what you're thinking. Well, wait a minute. Should we even get to the moon before we start sustaining it? And we're going to talk about all that stuff in the coming hangout. But first, I got a couple things I want to say. First of all, give me a quick shout out in the chats. If you're hearing me okay, I need to know about the audio levels. If I'm too loud, too quiet. You guys are always really good about letting me know that. So this would be a good time to do that. These hangouts, as most of you know, but I'm going to say again, are brought to you by the American Astronautical Society. They are kindly supporting this endeavor, and this allows, one of the great things about it is this gives us all a unique and an exclusive opportunity to get access to some of these big thinkers in the community and the leaders in space exploration. So this is your chance to directly interact with some of these people in the space exploration industry. And the AAS is united through a membership which creates awareness and opportunities for the space community. That's what they do. And if you would like to support the AAS, I would encourage you highly to do. Thank you, Raj. I would encourage you highly to go and do that by clicking on the link down in the description box. I put a link to their website and their membership. So please consider supporting the American Astronautical Society. And because if you do, then it'll give you the ability to stay up to date on some of the latest space exploration and science developments by giving you direct connections with the space community and network and industry leadership, their participation in a variety of AAS events. You guys have seen these. I've gone to the Von Braun Symposium. I've also gone to the John Glenn Symposium and streamed from there, so you guys know about those. So those are just a couple of the events they do. They also do the Goddard one and others. So, and these are for members only. And you can also get access to their technical publication, the Journal of Astronautical Sciences, as well as their e-publication, Space Times. So they're a really great organization, and they advance space exploration through all of these connections that they have. They offer insight, credibility, and leadership. So please consider becoming a member at astronautical.org/join. The link is in the description box. Okay, so thank you all for joining me. As a personal note, I am so happy to be back doing these again. These are one of my most favorite things we've ever done. I am streaming on not only the Deep Astronomy YouTube channel, but the AAS, the American Astronautical Society's YouTube channel. It looks like we've got some viewers there as well. I'm also on Facebook, Twitter, and my Twitch channel, all under the Deep Astronomy handle. So check out all of that. I'm looking at all of your chats on all of those different platforms. And yes, you've noticed my Corona cut. This is my coronavirus due. We got a pair of clippers last week, and Charlotte cut my hair. So yes, I am enjoying a very nice maintenance-free haircut. Okay, so let me bring up my panel. Here we go. I don't know what they are relative to each other as far as location, but according to me, in the upper right next to me, right over there, is Rachel Klima. She is from the Johns Hopkins University Applied Physics Lab. Welcome, Rachel. Thanks for joining us. And right below me is Niki Werkheiser. She is the NASA's Lunar Surface Innovation Initiative lead. Welcome, Niki. It's good to have you. And finally, over here in the diagonal of my Brady Bunch panel, I have to get my thing right. There he is. Clive Neal. He's from the University of Notre Dame. So thank you, guys. Going to the moon. First of all, let's talk about why we're thinking about sustainability. Who wants to give us an idea of why sustainability is important? I know most of us know that there's plans to get out there by 2024. More or less in a variety of different ways. We've got the NASA Gateway thing going on right now, which will hopefully be something built in cislunar space, something I'm personally very excited about, so I hope that gets built. I guess we'll start with you, Niki. Do you want to talk a little bit about NASA's role, and not just getting us to the moon? We know you're getting us to the moon, or at least working on that, but what about the sustainability part of it? What's your role in that?
Absolutely. So actually, we were just all kind of laughing first about the word sustainability and how it can be quite emotional even sometimes, in the sense that you may have 10 people and have 20 definitions of what does sustainable really mean to you. From my perspective and from what we're trying to do with the Lunar Surface Innovation Initiative that is part of the NASA Space Technology Mission Directorate, is to really first and foremost make sure that we are establishing an ambitious, cohesive, and executable strategy for developing technologies for the lunar surface. So what that really means to me is sustainability means infrastructure. What are the basic power and ISRU, or in situ resource utilization, extreme access? How do we get where we need to go and survive the night through the extreme environment? Can you hear me okay?
I'm sorry, it's my headphones. Keep going. I'm sorry.
Okay, good. That's me. And how do we mitigate things? Dust mitigation. Dust was a huge lesson from Apollo. How do we mitigate this? So being able to make sure that we are enabling and developing and demonstrating those technologies on the lunar surface is really what allows us to execute a sustainable strategy with government, industry, academia, and our international partners, which is, quite frankly, for me, the most exciting part of this is we're doing it together. Not only are we doing it together, we have to do it together for this to work. And that's kind of the other extra component that we see since Apollo is really the public-private partnerships. I firmly believe that in addition to the government, to me, the really exciting part is working with industry and academia, as well as our international partners, to understand that value proposition for establishing those infrastructure areas. So I'll let Clive and Rachel chime in on their interpretation of that.
Okay, Rachel, you want to go next?
Sure. Actually, what Niki said really feeds well into what our role is at APL and in trying to facilitate the Lunar Surface Innovation Consortium. We've been tasked by Niki and folks in the LSII to really work towards bringing all of these different members of the community together. And there's been a lot of work for decades of lunar advocates and exploration and science. But this is a very concerted effort from the technology side to make sure that all of these pieces that have been kind of moving on their own in different ways come together and build towards understanding what we need to develop these technologies, to invest in these technologies, to share information in an atmosphere where there is proprietary information and whatnot, but to make sure that we're not working in parallel and spinning wheels in different ways without communicating together. So APL, what we are going to be doing with the Lunar Surface Innovation Consortium is reaching out to the different stakeholders, trying to provide a centralized location for sharing the resources that already exist and for helping provide a voice back to STMD as far as what needs to be invested in to get some of the large hurdles crossed. So one of the other big aspects, I think, towards sustainability is to bring the partners in to share where they can as far as mentorship and bringing some of these established space companies in to help a lot of the burgeoning commercial space industry to learn how they themselves can become sustainable and use their technologies in other creative ways, because the economy is not going to be there immediately, so to try to share advice and a vision on how you can make enough money off these off your investments now, so that they will be able to continue to be developed while we're building up the infrastructure on the moon.
Okay, Clive, do you have anything you'd like to add? I can't hear you. Are you muted?
Wait, how about that?
There you
That's
are.
right. I was too busy coughing and spluttering here. So I think the definition of sustainability is something that we need to look at carefully. I look at the Artemis rollout document that came out on April the 2nd from NASA. And in there it says, we will develop new technologies that advance our national industries and discover new resources that will help grow our economy. All right, so we have something there. It's about jobs. Let's just get down there. We can make it sustainable because we are now using or leveraging the budget, which is taxpayer provided, as an investment in the future of this country. And how do we go about doing that? Well, that document very subtly tells us how it's going to do that. We're going to live off the land. We're going to need oxygen, and we're going to need water to keep astronauts alive. But we're also going to need that for a transportation infrastructure. Well, if we could figure out how much is going to be needed initially and how that could grow, there's a price point that could be put on that to actually get private industry interested in these things. So there's potential here to start putting, quantifying that initial great start on the Artemis rollout of how we can make this sustainable. And that does require looking at living off the land, using the resources that we know there, and actually figuring out if they're reserves. And it's a subtle difference. A resource is something that we know may be useful, and we know it's there, but we don't know how much. We don't know how easy it is to extract. We don't know what the amount that can be extracted and refined and stored. There are a lot of unknowns there that need to go into it. So when we see this Lunar Surface Innovation Initiative coming in that are actually going to start looking at the technologies needed to do this, I get very excited. I think this is now very different from the vision for space exploration. It's now something that is bringing in industry, it's welcoming private sector in, but it's showing us the milestones that need to be achieved in order for them to come in. And so, yeah, I'm very excited about this, and I think we can have a very good definition of sustainability in terms of a return on investment from the taxpayers' investment that is NASA's budget.
Okay, well, you're not the only one excited. Dave Draper is too, and you know why? Because he says it's good to see that you've got your regular khaki shirt on. So
I'm back to normal, Dave.
Yeah.
Just, watch out, mate.
That's right. Okay, I've got about 1 billion questions, and I see your questions too, guys. I see Raj, I see yours, and Dennis. I'm going to get to them here a little bit. I just want to get down a little bit further down this rabbit hole here. So when I was at the latest Von Braun Symposium last year, and one of the things I heard from NASA was this idea, and I think this is really a strong idea, is that they want to first be a major player in building a space economy. You've all mentioned that in various ways. They want to, and they will do that, I think, by being the first source. You know, with every economy, there's a supply and there's a demand, and they want to supply a demand such that these other companies can be the suppliers of it. They will be their customer, with an idea that eventually there will be more customers going out there in this economy, and then they can take a less of a leadership role in that regard and just become a customer like everybody else. I think that's really smart, and I think that's a good use for NASA and its resources and and budget. But I'm getting a little concerned about the moon. So we're hearing a lot of different things. At first, I was under the impression that the Lunar Gateway was going to be part of getting us back to the moon, and this dovetails in with where'd it go? I'm sorry, I need to. There was a question here. Oh, here it is. Dennis Just, has the Gateway been taken out of the critical path to the moon, and has it changed the approach towards sustainable lunar operations? That's the exact question I have too. So who can take that for us? What role is the Gateway going to play in not only sustainability, but getting us back to the moon?
So I don't want to speak for all of NASA when I say this, because
go ahead.
I've
You can
focused,
do that. I give you permission.
Sure. This is recorded, right?
Yeah.
So I focus, obviously, most of my attention is on our lunar surface objectives. I can say, though, that Gateway is still very much part of this overall story. And it is very much fundamental to what we're doing. As a matter of fact, I think it was March 13th or right around then that they announced the first two science payloads. I think one was ESA, right? And then also the SpaceX would be the first commercial provider to deliver cargo and experiments to the Gateway. So we are definitely progressing down that path. And in moving forward toward that.
But is it part of this critical path? And I guess what we mean by that is it part of actually getting us to the moon, or is it now a parallel effort?
I think it's part of it is still a critical path for the overarching plan for Artemis, and then how we also learn from the moon and continue on to Mars, which is part of the overall agency plan. Maybe what you're referring to is it in the critical path for that first 2024 boots on Mars?
Yes,
boots
that's
on
what I
the
mean
moon?
anyway when I talk
Right.
about it.
So the overarching plan, I don't think anything has changed there in terms of if it's critical path for that first boots on moon mission. I think it's being refined, that the programmatics for that and how we make sure that we meet that goal. Yeah.
Can you give us your opinion on this 2024 timeframe? I know you don't speak for NASA. I'm asking for your personal opinion as Niki, the person in my hangout. Do you have an opinion on this, of as far as, is it a reachable goal?
So as an American taxpayer and as a space nerd from way back, I do, absolutely.
Okay.
And I'm very optimistic. And the reason I'm optimistic is we are not doing this in a bubble. And I think the plan that is being developed, because we're doing it, we're creating this plan along with industry and academia and our international partners, is an executable one. If we have to refine along the way, we're doing that all together with all the stakeholders, because it's not just a paper plan. It's something that we have every intention of executing. So absolutely, I'm very optimistic about that, and I believe we'll do it. And this is why the very first thing we did was to establish the consortium as part of LSII, because we want to truly understand what the value proposition is for industry and academia. We could go off in a vacuum.
Do you mean profit? How they're going to make money?
I mean, when we put out solicitations for public-private partnerships where industry and academia are putting skin in the game, right? If you're going to put skin in the game, we need to make sure that we're working toward the same. When we put out that solicitation, it's the same goals, the same objectives that company has to do with the part that they need to do, right? So if we all need power, right, then how much power do we all need to get to excavate and to mine and extract our water and process? Then we all know we need power capability. So if our solicitations are focused around that and we're having these iterative discussions with industry and academia, and so in the public-private partnerships, we're targeting the same thing that company needs anyway to meet their objectives, then that makes sense collectively, right? We're not coming up with these requirements off in a vacuum. Yeah.
Well, I'm lucky in this hangout that I've got a lot of people ready to drive this hangout for me, so I'm about to give them control by asking their questions. But before I do, Rachel, just real quick, can you get, and then I want Clive to do the same. Rachel, tell me a little bit about your particular interest in sustainability, and maybe give us some insight into APL's role in this. Because sustainability on the moon, that's like saying space exploration, right? It's a very nebulous thing. So, I mean, what are you thinking about with this topic, and what's APL in particular interested in?
Well, I don't want to speak for APL in particular, but
God,
so I'm only
I mean, I have you go ahead.
I'll speak for APL and NASA if you want.
There you go, Clive. Okay, good. You're last. I'm going to let you speak for everybody. I will too. I have no problem with it. Go ahead, Rachel.
Well, so my background is, it's originally geology, right? But I've been in planetary geology now for 15 years or something like that. And so, I'm extremely excited about what having the infrastructure and a sustained presence there means as far as learning a lot about the science. So as part of the consortium, I'm very excited about bringing the different groups together and helping to bring everyone along, and not just, I think when we look at how things have been done in the past, it's kind of like the Star Trek world or whatever that we grew up on, where we want to have everyone invested together and really bring the entire of humanity to really build through from the moon and onto Mars and wherever. So my personal excitement is the idea that we're really, it feels like on a path to build that future that we all dreamed about as kids, so.
The moon bases and the bubbles and the walking and the driving in the cars. Yeah, man.
Or something, but just to really, to really see the value in that, and to start having people living off planet for longer than a couple days. I mean, it, yeah, maybe not flying cars and all of that, Jetsons, but,
Well, definitely the
but yeah,
bubble cities, man, and the little cars
yeah,
that drive around and tunnels. I'd be happy with just what Andy Weir wrote about, with Artemis, or so that would be a
yeah.
good future too. Okay, Clive, what do you think? What's your little interest, your primary interest in this?
My primary interest in this is to see the 13th human walk on the moon. I saw the first 12.
Me too.
It's I don't think I'm going to be around to see the first human walk on Mars. I hope I am. But the thing is that we now have, with the moon and Mars, we now have a pathway to make that a reality. There are people out there of my age that say, no, we should go direct to Mars because I want to see humans on Mars. I think you're being a little selfish there. I think we have a workable program now, and I'll focus on the resources. We now know, because of the science done on the moon, there's water ice on the moon.
Yep.
There's water ice on Mars. We know that. That's a resource. So we can look at the extraction of the resources on the moon and Mars and refining them. You're going to be using very similar technologies in different environments, but that's the resource. So we have a pathway, and we have our lab in our own back garden where we can go test these things that is close. It's only 3 days away, or 7 if you go through Gateway, but we'll quibble over that later. But it's important that we test these things in a way that will allow sustainability on Mars. Now, sustainability on the moon, because it's close, we've got a very vibrant low Earth orbit and Earth orbit economy going on. It's not going to take that. It's not that stretch of the imagination to expand that to cislunar space. So, well, what's the demand for that? Well, having human permanence on the moon creates that demand. You create that economy. You create that sustainable return on investment. The economic growth and jobs. I want my students at Notre Dame, when I say, what are you going to do after Notre Dame? Oh, I'm going to go work on the moon.
Yeah.
I think that would be pretty neat.
Exactly.
So that's my interest in here, is that, again, we made great steps back in the late 60s, early 70s, and then stopped. We've made great steps in Earth orbit, but we now need to go beyond that. It's time, because not only is the government backing there, but unlike Apollo, we have a very vibrant commercial sector that will help. We can leverage economic growth from, and
Right.
That's the investment that I see NASA is making, and other space agencies. And I see not just NASA being the customer, but space agencies being part of this initial customer for those commercial services, for those products.
Very, very well said. I couldn't agree more that, first of all, the last time we did this, I was a kid, and now I'm an old man. So yes, I would very much like to have this this capability back. And I think
I'm still a kid. I just
I'm
don't
not.
look in the mirror that
I'm
much.
an old man. So, but yes, I mean, I hear you, and I'm glad to hear you say that this is in our own backyard. This is a thing we can do with the resources that we have that are reasonable and affordable, and that would lead to an economy. And I think that part is important, because it is part of a sustainability thing. I love Robert Zubrin, but every time he talks about this, he gets really angry about going to the moon. And I'm like, dude, he thinks we should just go straight to Mars, forget everything else. Let's just go to Mars. And I'm thinking, you know what? That's going to kill us. We need to think about that. We need to have more experience outside of Earth's magnetosphere. And I think this is the right way to go. So the Gateway, getting to the moon, let's have a presence there, and let's use that experience and build that economy, and then let's go to Mars. Manifest Destiny didn't go from the eastern seaboard states to California. It went through all the other places in between. Okay, we could talk about whether that was the moral thing to do, but it ended up happening that way. We didn't just jump to California. And so there's a practical reason to do this kind of thing. First of all, distance, right? And being really close by has I think an effect. So amen, brother, is all I got to say to all that stuff. So, okay. So let me get to a couple questions here, because they're really good ones. Raj Luthra wants to know, is the deep space transport Moon/Mars transit vehicle still going to be built? Does anybody know?
I don't know.
Okay. How about this from Raj? Can the moon's surface help to grow food? Is there a way we could have agriculture there? You said live off the land. We know there's water, but that's only part of it. Will the lunar surface let us grow things there?
Anybody else want to take this?
You can start if you want, Clive. I can add in.
All right.
All
Okay.
right.
So if we look at the experiments that were done with Apollo samples when they first brought the Apollo samples back, it was more in light of toxicity. So crops were grown in terrestrial soil, and some moon regolith was sprinkled on the top of it. There's been a push to try and grow crops in lunar regolith, and that has not yet been done. However, what we see is that it's a volcanic soil. If we go to the Mare regions of the moon, volcanic soils are on this planet very good for growing crops. They lack the organic material. Now, everybody remembers The Martian. Humans are a great source of organic material.
Yeah.
So again, we know what needs to be added to the soil. What we need to look at is the radiation environment for those crops. Would the actual value of those crops, or the food value of those crops, be diminished because of the radiation environment that we're protected on this planet? So if we take foodstuffs up there from this planet, how quickly will they degrade? And these are things we can learn on the moon before we go to Mars.
Yes, exactly. So the volcanic kind of lunar soil added with organic material, you say, is promising.
It doesn't contain everything it needs. I mean, there's very little carbon, very little nitrogen in lunar regolith, unless it's been exposed to the sun. Those are implanted by the solar wind as the sun. So the sun is bombarding the moon. If it's been exposed for a long time, there is some there, but they're at very low levels.
Okay. Niki, did you want to add something?
Yeah, I'll just add to it and say that I think for any long duration mission, we're all very aware that food supply and how we manage our food in general is a big issue, right? Not just from the obvious physical aspects, but also the psychological, and having appealing food over a long time. You can only eat so many potatoes, just ask Matt Damon. So in terms of a space technology mission directorate, our main job is to develop and demonstrate the technologies that we need, and to retire the primary technology hurdles, the foundational technology hurdles at a relevant scale for any given capability. So we are doing things like we have a synthetic biology project that right now has experiments on space station, a whole cycle experiments that have been going on for 5 years, where we're looking at multiple things. But one of those is how you could grow food. I think their next step is even looking at, I think the astronauts have been requesting some yogurt cultures and things like that. As well as in our in-space manufacturing project, we do 3D printing. There's a lot of thought terrestrially and obviously the benefits for space missions of working with industry on using stem cells to pretty much 3D print, use that as your feedstock to 3D print food. And there have been companies that have actually even in universities that have actually 3D printed chicken and steak that you can control some of the nutritional values and even marble it and give it the same
3D
texture
printed
and taste.
steak.
Yeah, there you go. Texture and taste very similar to what you get on Earth. Of course, we look at things like algae as well that doesn't taste quite as good. So the packaging, the form, fit, and function matters as a human. So in addition to what we can do on the moon or Mars, in addition to crops, we're looking at how we can use technology too to help maintain a food supply.
Okay, good. Well, I got a question here from Nathaniel Harmon. He's 10, and he's asking, will it be easier to grow plants on the moon's surface because of low gravity? Does gravity help us grow things? Or low gravity, I should say.
I think if we look at Station, they've been, and I'm not familiar with these experiments, but they have been growing plants in microgravity, have they not? And
Yeah, the Veggie experiment led out of
Yeah.
Kennedy Space Center, and
There
there's
we
been a
go.
lot of university improvement through our space grant and the Exploration Habitat space grant mechanism, and they've had a lot of good. I mean, it's still an experiment, and they're still testing. And that's an excellent question to ask. I love the way he's approaching this and thinking about it, because we don't know what we don't know until we try something in microgravity, and most of the time there is some unknowns that we did not expect. But I think they've grown some lettuce in the Veggie experiment that's went quite well, and the astronauts have eaten it and are really enjoying that fresh grown lettuce.
Okay, R.D. Silva's asking, is there any progress on using quantum computing for communications for the lunar base? Communications are going to be vital, right? We're going to have a constant link back and forth between any kind of lunar base. What's the communications aspect of this, and particularly, is anybody using quantum computers? Any idea?
I don't know if anybody else wants to answer, but so there's a lot going on with COM. We work with our Human Exploration and Operations Mission Directorate, HEOMD. They have the program SCAN that is helping to develop the communications needs, and I work closely with our Flight Opportunities Office for some of our lunar COM relays, some of the early demonstrations that we're planning, and looking at how we can use flight opportunities and the CLIPS, the Commercial Lunar Provider Service through SMD, to test some of these out. As well as ESA has has been interested too in flying some early demos for COM packages as well. So that's one of those areas, again, when you talk about the basic infrastructure needs that you have and how we can develop public-private partnerships in approaching the COM strategy and what the best technologies are for that.
Yeah, and one of them was it's a related but not direct technology. Is I think it was Aerospace Rocketdyne, I'm not sure, or Aerojet Rocketdyne, that launched the atomic space clock that is out there now. Recently went up in one of the SpaceX missions, and its goal is to provide a time source that can be reached from deep space, so that we can have things like GPS and other navigation ability outside of just sending things back and forth from Earth, because obviously, for obvious reasons, that travel time gets to be a problem. So that's another area which is being worked on now too in the infrastructure department, which is navigation. These deep space clocks are being built and launched now.
Yep,
So,
and that's out of our STMD from our technology demonstration mission program.
was that from
It's
your
going very well.
innovation team there?
Yeah, Deep Space,
So you know what?
Deep
you know all
Space
about
Atomic Clock.
it. Yeah.
Yeah.
Well,
And-
also on the Laddie mission a couple of years ago now, there was
right.
a lasercom tech demo that went very well as well. So these things are
And remind people
working
about
out.
Laddie mission real quick.
The Laddie was the Lunar Atmospheric and Dust Environment Explorer, if I remember my acronyms correctly. And it was looking at lofted dust around the equator of the moon. But that was also a laser communications tech demo. As far as quantum computing, geologist, so not gonna be able to help you much there. But I think the communications side of that of any Artemis base camp or lunar base is going to be critical, and I know that there are a number of commercial companies out there looking at that in terms of setting up communication satellites around the moon.
Right. Good. Varun Vanga is asking, will the U.S. try to use the moon's low gravity to get to Mars quicker and more energy from the fuel on the moon? So I guess that's this idea of using the moon as a starting point to get us to Mars. Is that something that any of you want to comment on? I think that's big. That's what the Gateway is mostly supposed to be for, is to be this sort of technology thing in cislunar space that lets us not only get to the moon, but build technologies that'll get us to the Mars. But maybe you guys have a comment on that?
No, you're exactly right. And that's why I was saying earlier that the Gateway is still very much a part of the bigger plan, regardless, because that is kind of the foundational module that will help us go from Moon to Mars.
Yep.
And then, of course, Clive, we can talk a lot more about the in situ resource utilization and how we could mine resources to help us, like he was mentioning earlier, doing those calculations with propellant.
Well, well, while we're on it, then let's go ahead and since you brought it up, Raj Luthra asked me if mining the moon will benefit sustainable moon operations, and it sounds like the answer is yes. But let's elaborate. Mining the moon.
Hold on a minute. Hold on a minute.
Why?
We've got a step that you've missed there. We've stampeded to mining the moon, but what are we going to mine? Okay, so let's back it up. Everybody,
what's it got? You know what? That's the answer.
We know the potential of the moon, because great potential, because we know that there are resources there. Now, everybody uses resources in terms, non-geologists use resources interchangeably when they mean reserves. Something that we know is there, that we know that we can extract it, and we can extract it economically and use those products. So we don't know if the lunar resources, especially the water ice and other volatile deposits, we don't know if they are reserves. The only reserves we do know is there is oxygen out of the lunar regolith, because regolith is everywhere. It contains pretty much the same amount of oxygen from Mare to Highlands, and we know that that's a reserve. But water ice, in terms of what we need for liquid oxygen, liquid hydrogen propellant, we still don't know if they are reserves. So the SMD Viper mission is the first attempt to actually go to the surface and understand if we can extract these volatile deposits. There needs to be a campaign of these, because that's how you do it on this planet. Is a prospecting campaign. And so we need to understand that first before we start mining. If we start to see that, this looks really good, then we need to understand a pilot plan. We need a tech demo. Can we actually create water out of material that's held in the regolith? Because we know from the LCROSS mission that there's other impurities, not just water ice there. So we have to refine those out. They can be useful products or they could be waste products. So there's a lot to do before we can start full-scale mining of the moon.
Oh, okay.
Exactly
that's a little
right.
bit of a bummer.
And
I was hoping we could just pick up some ice, melt it, and run it through a Brita filter, and we're good, man. But it sounds like no.
Well, and this is why the early missions are so important. So we do have a strategy for doing exactly what Clive is referring to. And so we have some very early demos. You mentioned Viper. We also have the Pillar resource mining, one that's kind of a predecessor or complementary to that doesn't include the mobility aspect, but takes the drill and the mass spec. We have to, hopefully the water is where we think it is, ice is where we think it is. We have to collect that. We have to assess it, and we have to really understand the composition of that as well. This is really fundamental foundational information we have to have. So the SMD, the Commercial Lunar Provider Services CLIPS missions I referenced, there are 14 providers now, which is very exciting. That says a lot right there. Mm-hmm. And planning those missions has been a huge priority, huge focus. And then so we're planning those in the early years, and then we have 2 to 3 additional technology demonstrations where we're doing trade. So we start with the ice mining because we need the answers that Clive just talked about. In parallel to that, we're developing high fidelity, high quality ground demonstrations for O2 from regolith processes. You have carbothermal and multi-electrolysis. You have different processes you can use that we're trading on the ground. And we've never really done a high fidelity demo on the ground of that in a vacuum chamber, in a thermal vac chamber, using really quality regolith simulants. So in parallel to developing that ice mining demonstrations, we're also doing these things on the ground. From there, that'll give us a lot of data, those 2 activities alone. We extract the key lessons learned from there, and we have 2 to 3 additional technology demonstrations planned in that 24 to 26 timeframe. What comes out of that leads to the what we're calling the ISRU pilot plant. Mm-hmm. It would be unfair to say today that, just like Clive is saying, I'd be lying if I told you I know it's going to use this process and be this big. But the important thing is that we have got the missions planned, and then we're asking the right questions. To me, especially for our 10-year-old viewer or that was listening in, always remember, in cases like this, sometimes the answers aren't the most important thing at this stage. It's asking the right questions and prioritizing those and acting upon those with that urgency and that prioritization. We all need that data. That pilot plant ultimately is planned for the 2028, 2029 timeframe. And everything we're doing in that strategy and that roadmap building up to that helps to ensure that by the time we get there, we've done what I said earlier, and that is buy down those technology hurdles, and that we can at least develop, I would say, in the hundreds of kilograms, maybe versus thousands, we'll see, but have a technology that we can depend on to do that.
Okay, well, that was okay. So that's really great, and I want to transition from that. I've been reading the chat, and by the way, thank you guys so much for supporting this stream. I'm really appreciating what the feedback and the support that you're giving us. So thank you very much, Susan Hunter and others, for doing that. But I want to read R.D. Silva's comment or question, and then I want to add to it. He's asking, is there any progress on using? No, sorry, that's not it. That was the other. Here it is. Will colonizing space in the far future have irreversible implications? And I want to rein that in a little bit about far future, and say that we have very little experience traveling outside of the Earth's magnetosphere. For example, the moon, obviously the Apollo missions were the big one, and we spent just a handful of days outside in actual space. And so my question is, in order to be sustainable, we also have to survive out there. And what are the big questions that are being asked about whether or not human beings can survive out there for any length of time? Anybody? Because I'm really concerned about it. I'm not sure space travel is even possible with human beings, because we were evolved to live here on this planet with a 1G gravity and and being upright and having our blood flow in a certain way, and being in 1/6G on the moon, or even something different on Mars. This all matters, not to mention the radiation. So what are we thinking about in terms of a long-term sustainable presence on the moon with regard to our health? And is it irreversible? Can we never come back? That was R.D. Silva's question. Are we stuck out there without being able to survive on Earth anymore? Thoughts?
So not to deflect, but the first rule is do no harm. So I'm not going to make things up since this is not my area of expertise. I will tell you that we work closely with our Human Exploration and Operations group, which is obviously a huge priority for the agency. I think there's even been some very recent studies that have changed some of the calculations and predictions there. But I will say that's why one of the main priorities too is our type of propulsion, and how we get there and how quickly we can get there, especially when you're talking about Mars, how much time we have to spend in transit and on the surface. If you have a lot more efficient, effective propulsion capabilities, then you're going to mitigate a lot of that radiation exposure. But that is certainly a huge question, and one that NASA is investing heavily in. Unfortunately, I'm just not the right person to answer the technical question.
Right, understood.
Yeah.
I wasn't sure.
Go
ahead, Clive.
I've dabbled in this. I've done a bit of reading, so I'm dangerous.
That's right. You're like me.
Yeah. So let's think about this. We have a lot of experience of the human physiology in 1G. We're getting more and more experience of human physiology and microgravity with station. It's coming up 20 years now where we've had humans up there continuously.
Yeah, but that's not fair, because it's inside the magnetosphere.
No, it's not what I'm talking about. I'm talking about gravity.
Okay, all right then.
All right. So now, we know the effects of microgravity? We know the effects in 1 gravity. Is that a linear relationship in degradation from 1 to micro? The moon is the place to go answer that in terms of gravity, effects of gravity on human physiology. The effects of radiation then become more acute if you go to the moon to do your gravity experiment. You're out of the Earth's magnetosphere. So it's that having that laboratory in our own backyard. Again, we now look at, well, how are we going to keep astronauts healthy as we go onto Mars? Well, we're going to have to give them some sort of gravity to sort of stop the skeleton dissolving, if you like. Well, do we need to give 1 gravity, or will 1/6 gravity be enough? Is that enough to stop that? We don't know. All right. So the other thing is, you've got your Mars exploration vehicle. We built it, and it's going, and it's at the moon, and it's being refilled with the lunar propellant, so it can go there with a full tank. And then they put a meter thick sheath of water around the capsule. that will protect the astronauts from at least ionizing radiation. So that comes down to them minimizing the time that you're actually out in deep space. So there are ways to do this which are quite low tech, but if you can do it at the moon in a much lower gravity well, the expense of doing that is then reduced. So I think we've got our lab in our own back garden that is an enabling lab to answer a lot of questions. And it comes back to what Niki said: got to ask the right question. Will there be a cutoff point where we're not going to come back? We don't know the answers to that. That's a question to ask, but we know the questions to ask in order to at least start to be informed about that type of answers to those types of questions.
It's a real bummer what we don't know. That's for sure. Michael Burke, thank you, man. You are a rock star. Thank you for supporting the chat. He's got a question. Why aren't the plans for Lunar Gateway to have a rotating hub, I think, to provide artificial gravity for long-term use? Is it a technology or is it money problems? Why aren't we rotating that thing?
It's unfortunate because my role is focused on lunar surface. So I know the Gateway folks, but I really can't speak for them and their design and architectures. It's just not what I'm going to say right now. Both. You got lunar surface questions. I'm all over it though.
Okay. Well, I'll get back to that. I just wanted to, Michael Burke, I'm going to say both, dude. I think it's both the technology and money problems. This is a big deal, right? Building this gateway is going to take a lot of technology invention, just like JWST took when they built it. So I bet you, since one of the purposes of this thing is to be a platform for technology development, that'll be one of the things that will end up getting developed on it, but probably not right away. Okay.
You also have to remember, though, I will add that the Gateway is not designed to be a long-term habitat. It is a high percentage of the time it is not crewed, so you want to kind of balance that out.
Okay. So Rachel,
10-year lifetime. 10-year lifetime for Gateway.
Right. And I think the use case for it is to put people up there temporarily, like you said, a few days to do what they got to do to get to the moon, and just to make the delta V to the moon different and all that kind of stuff. So, yeah. So, Rachel, you said you're a geologist, correct? Planetary geologist?
Yes.
In your opinion, what is the most important geological aspect of the moon that makes it sustainable? Clive mentioned something about oxygen being in the regolith, but is there anything else that you're looking at in the moon's geology? First of all, is it active geologically? And second of all, what are some of the things that you're looking at for the most promising things we can take from it?
Well, that's a good question. So what I'm personally super interested in is how planets evolve, which is not really, with the exception of maybe the water case and how much water was actually present in the moon as it evolved. I think that maybe that's the biggest crossover as far as resource potential, as well as my interest of just how planets form in general. So I've done a decent amount of work with looking at remote sensing of the moon and looking at trying to figure out whether there's actual internal water that we're seeing from orbit, which is extremely challenging because we know that water is probably being produced on the surface through implantation of solar wind hydrogen bonding with the minerals. So we have this overprinting of some amount of water that we don't know. We don't know how much. We don't know how thick this goes. We don't know how deep it goes. Whether we're seeing a very thin few monolayers, whether we're seeing a deeper reservoir when we're looking with some of the remote sensing instruments. Then we know at the poles from things like LCROSS that we've got deeper, thicker reservoirs. We've got evidence now from multiple instruments that there could be at least some kind of icy dirt or dirty ice of some sort to some depth. But, one of the big questions I'd like to see answered that would also be helpful to a sustained presence is, how much water was in the interior at the time that the moon formed, and, is internal to some of the minerals that we're seeing. Because with Apollo, we've thought of a very the evolution of the lava as being very, very low in water typically until the last 10 years or so. So I guess that would be the big crossover is what is the actual internal water inventory of the moon.
What's
as
the
far
best
as
way to
within the
figure
rocks
that out?
themselves.
Is
What's
it,
that?
what's the best way to figure that out? Is it like something like the Mars InSight lander that had that probe? Of course, I know they were looking for earthquakes, but or Mars quakes. But what's the best way to find out the internal water content of the moon?
I think sampling in the right places.
Just digging a hole?
Well, and or bringing back rocks or finding a good way. We really would like to have them brought back
Yeah,
as
yeah,
geologists.
sure.
So getting people to the right places to collect some of these rocks that we know are very unique geologically. So some of these things like the silicic domes, some of them we've seen being associated with water in the remote sensing data, whereas a lot of those rock types that we have in the sample collection from Apollo don't show high amounts of hydrogen. So resolving why we see it from orbit in some, is it just what we happen to bring back from Apollo is not representative of the moon as a whole, or if something else is weird is going on as far as that we're seeing what anomalies that are solely due to surface water implantation over these bodies. So yeah, I'm going to nerd out too much into the geology side if you let me keep
Nerd
going
away.
here.
Nerd away. We love it. I love it. Okay, so it's shocking that we don't know more about this stuff. Actually, any plans to do this kind of thing where we're trying to get some clue into the internal structure of the moon's composition, not just like where geologically, but I'm talking about compositionally, like the elements and things like that. Is there anything underway to figure that out?
So I feel like Clive's being asked about ILN, right?
Yeah, I'm leading the team formulating a geophysical network to be put on the moon as part of the NASA New Frontiers 5 competition. We're going to propose that. If it gets selected, we will be able to, because of the instruments we're having on each one of the landers, we will be able to define deep moon composition as well as structure because of that. So that is something that was sort of done on Apollo, but the network was very narrow on the near side in terms of the seismometry. So we have a very poor idea what the far side is doing and what the deep composition is because of the narrow window that we had. So we're looking at putting landers on the far side as well as the near side, and to listen. They're put down and they're just going to be listening for at least 6 years, hopefully a decade, to the moonquakes and understanding the structure from that, but also taking magnetic and electrical readings to understand the internal composition in terms of magnetic currents and electrical currents, which then feeds into heat flow, and we can then define composition, bringing in the seismometry with that. We can back those out to constrain not only the data we're going to get from this mission, but also the gravity data from Grail will be much better constrained in that way and a lot more useful. So, well, it's been pretty useful so far, so I won't diminish it by saying that, but it will enhance it greatly. So there's some plans there, and that's in my spare time. I'm working on that because my full-time job is teaching, of course. And so I think that I'm hoping that there will be a lot more information coming up in the next 10 or so years.
Okay. So Kenneth Morse is commenting, have to go to my next meeting. Nice work to all of you, and Rachel gets my vote for having the coolest house I have seen so far in the background. Also, Dave Draver wants to be clear and say, Tony, we know a lot. hard to get it all across in this forum, but don't be shocked. We know a lot. Well, you know what that means, Dave? That means that you have to get on here and tell me what we do know.
Exactly.
You know, you gotta. So you're invited. Okay. And Jim's here. Jim, he's asking, what's a more favored location for investigation? Is it the poles or the far side? And I would just add, are you guys paying any attention to the Chinese rover that's over there, the Chang'e 4? I think it is.
There's a Chinese rover over there.
Yeah.
What?
Yes.
Rachel, I'm going to let you take that one.
The polar far side, is that allowed to say
The polar
that?
far side. So both is the.
Yeah. So yes.
Yes.
Yeah, thank you for asking.
Option
Jim.
C.
So-
That's right.
Yeah.
Yep.
okay, so the South Pole seems to be very, very interesting these days.
I like the North Pole, but that's just me.
You're just being contrary, though, aren't you?
Yeah, well, there are shallow moonquakes in the South Pole that were detected by Apollo, and these have magnitudes up to 5 or greater. And when one of those little buggers goes off, it tends to sort of shake the ground for 10 minutes. So there weren't any detected up near the North Pole.
Okay.
So I wouldn't want to put a base on an epicenter of a shallow moonquake. So we probably need to figure that out.
Okay. All right. Well, Dave, then if you're available, then email me, tdarnell@deepastronomy.com, and let me know, and I will get in contact with you. So Jeffrey Gills Davis is commenting, the Outer Space Treaty indicates nations can't mine, but it doesn't cover private industry mining it. Thanks, Hans. The industry just signed, the president just signed an executive order to support moon mining. So that's weird, because the Outer Space Treaty doesn't let countries do it, but private companies can do it. Is that part? I mean, I know you guys aren't into treaties and stuff, but probably, but you know,
Yeah.
that's interesting.
I am not a lawyer.
Yeah,
so.
it's like space lawyering, isn't it? That's like a thing now. Just ask anybody who's watched Elon Musk launch 400 satellites up into space and ask the question, can he do that?
The answer is yes, he can.
Yes, he obviously can. And he's got 42,000 more lined up. So yes.
So the lawyer issue, there is a group out of The Hague that have looked at the resource utilization, space resources. There's also COSPAR, and I can't remember the acronym for COSPAR. That's an international body that also covers planetary protection and resource mining and so on and so forth. So they have an opinion. Now, it appears that the United States has a different opinion. But resource rights, that's something that is going to be certainly above my pay grade to think about.
Well,
we've got a lawyer
we probably shouldn't go there
already.
All right. Okay, Dave, thanks for being a part. In fact, I got to close out because we are out of time, and I want to respect my guests' time. I don't want to spend longer than I promised them. So I want to thank all of my guests, Niki Werkheiser. I'm sorry I keep doing that. Rachel Klima and Clive Neal for joining me. They are all helping us get to the moon and get there sustainably. I want to thank the American Astronautical Society who organized this hangout. We've got more coming, so please stay tuned. And I would like to remind you guys to please think about the AAS membership because they are advancing space through connections, insight, credibility, and leadership. So become a member at astronautical.org/join. And you can follow them on Facebook, Twitter, and Instagram, all at Astro Society. In fact, I had, if I go back to this is their Twitter handle. Where is it? Point the right way, Tony. Boy, this mirroring. There it is, right there. Okay, there's Astro Society on Twitter. And so please check them out. I want to personally thank Jim Way and others at the American Astronautical Society for putting this together. This has been a lot of fun. Thank you all so much for watching, and I will probably be back next Thursday on my own if we don't have another one planned for the Future in Space Hangout. So thank you all so much for watching. And as always,
Dave Draper's going to be there next Thursday, right?
I guess Dave's joining me, right?
I nominate Dave. Let's throw him under the bus now.
Yeah.
Come on, Dave. Come on, Dave. The bus is here. Come on, back up. So anyway, all right. So thank you all so very much for watching.
Thanks for the opportunity.
Yeah.
Onward and upward.
Thank you very much.
Onward and upward, absolutely. Okay. And as always, keep looking up.